Okay, hello everybody, and thank you for joining this session. In today's video, we are going to see three different keywords that are applied to methods of subclasses in C#. The first keyword we are going to see is the base keyword, which also can be applied to constructors, but in this video we are going only to see how to apply to methods, to subclasses methods. Then we are going to see the new keyword, which is the same keywords we are using when we create objects, but when we apply to subclasses methods, the behavior is different, and we will see in this video later how to use it. Then we are going to see the seal keywords, which is applied to overriding methods in subclasses, and is applied to actually methods that are derived in the subclass from relative methods in its parent class. This is actually a very specific situation, and we are going to study in this video later how to use it. So before we start to experiment with these keywords, I would like to spend some words about the polymorphism aspect of object-oriented programming, because all these three keywords are pertaining to this aspect of the language of C#, and so I would like to actually to punctualize, to highlight some the three aspects of polymorphism in order to understand where these keywords are applied to, because these keywords touch the three aspects of polymorphism. The polymorphism in object-oriented programming can be applied to three different layers. One is ad hoc, or a method polymorphism, which actually is the method overload, when in a class we have more methods with the same name but different signature. So we can access, when we create an object, we can access each of these methods by using the signature, the relative signature. Then we have another type of polymorphism, which is inclusion polymorphism, and this actually is the overriding polymorphism. This is actually applied to methods that override the relative in the parent class. So this actually applied to a subclass that is going to use the same name and signature of a relative method in its superclass. So this is actually also an aspect we are going to see when we are using the keywords we are now studying. Then we have the covariant polymorphism, which is when we have a superclass object which is created from an instance of its subclass. Then I would like to spend some words about the tool I'm using here for this video, and it's repl.it, which is an online cloud development environment, and This is actually a tool that I use personally to test piece of programs, and also because the clouds supports many programming languages and are easy to switch when I need from one program language to another. Okay, now we are ready to start and begin the discussion of these three keywords. And so the first thing we're going to see is the program which I created for testing, and I created a superclass with a number of methods, and some of them are virtual, some of them are not. Then I created a subclass which inherited from the superclass super. I call this subclass sub. So by the name it's easy to identify the classes as a super, as a parent and child class. Then I created also another sub-class which inherit from sub, but here we are going to discuss this subclass later, because it's a specific application, and so mainly we are going to work with these two classes, and this one is just for one to explain one example, one keyword. Specifically is the seal keyword, but we are going to see better later the purpose of this class. Okay, so then after that, after I created all these classes and subclasses, we are going now to see the program that is going to be executed, and so here we are created some the objects of a subclass, of a superclass, another kind of object, and so on. So we'll discuss actually all the scenarios we had to work with these three keywords. So let's now focus the attention to the output window, which is this one. And okay, the first one is I'm going to discuss is the creation of the subclass here and the keyword base. So with the keyword base, we are going to access any methods which are visible outside the class. So for that, it's not any methods, for example, that is not declared as private, because of course private methods are only visible inside a class and not can be visible outside. We know that, right? So any method that is not declared as private in a superclass can be accessed in the subclass with the base keywords. We are going to see this first one, okay? So I just put this line here, this written in an output, this printed in output, just to identify and divide the rest of the output with these base methods. This one, because actually we are going to know that we see here is method 1, right? Overriding method 1 in the parent class. So the child class is overriding method 1, and inside the body of the child class we are going to call base method 3, which is this one. So we are going to call method 3 in the parent class from the child class, and then we continue the program with some other code, and here we write another line. So how we can see here is we understand that base class is actually give us the the possibility to access any method. Of course, these methods, as I said before, must be visible from outside the parent class, and can access any method, and actually give us the power to manage the method of the parent class inside a method in the subclass. Okay, then we are going to see the new keywords. New keywords is actually widely used when we are going to create an object. So what we are going to do with a new keyword? With a new keyword, we are going to hide the method from this child class, the relative method in superclass. So let's take the example of these two methods here, method 2 and method 3. As this one has declared, is actually hiding the relative methods in the parent class. But we see that the method 3, implements the new keywords. Let's see what is the difference now with the output. The program doesn't give any error. I mean, the compiler is actually compiling the program normally. There is no error and everything goes smoothly. But he actually provide us from the output window, give us some warning. And if we go up there, here, in the output window, we see that there is something coming up from the compiler, and there is this warning here. As a submethod 2 hides inherit method super method 2. Use the new keyword if hiding was intended. So actually, what does that mean? This means that actually the new keyword is actually just for I mean, readability is not required by the compiler itself. It's just for having a clear picture of what is going on. And we know when they have complex programs and the code is starting to be articulated, maybe having some explanation, good explanation, we know that we are intentionally overriding the method 3 here. Here we do the same thing with method 2, but it's actually not explicit. It's something that we obtain the same result, but if someone else is going to read this program, he said maybe this one is mistake. So at this point, maybe there is some question that might arise, and this okay, but what is the difference between hiding a method and overriding a method? I mean, at the end of the day, we are going actually to obscure, right, the method that is in superclass. So what we do in the child class, in the subclass, actually with the method with the same name as signature, of course, we are in some way obscuring what is happening in the same method in the superclass. So what is the difference between hiding a method and overriding a method? To understand this, we have to use the covariant aspect of polymorphism. We are going to see now that we actually use the covariant aspect in this statement here. So we have a super type created by the subclass. Actually, when we are going to run this program, we see that in the output, we see where is the difference. Okay, here we see that we are going to actually execute the method in superclass, right? Because we are hiding the method in the subclass, but we are not overriding. So what is actually here put in evidence is actually that the methods we are going to use and to execute are the ones that are specified and declared in the superclass. So method 2 and method 3 are executed the one that is in the superclass. If we see now what happened in the method 1, which is overridden by the child class method, relative method, we see that actually what is executed is the code inside the child class method. So here he executed the method, the code that is specified in the child class method 1, while here, these two lines here, the methods are hidden in the subclass. In this case, the code that is executed is the one inside the method 2 and method 3 in the superclass. The last thing I like to see is the application of the covariant polymorphism in this line. Here, the type of this object variable is super and is created by instancing a subclass of super. In order to understand why we can do that, let's think about reflection of objects and classes. So when we reflection, without going into much details, reflection is actually the metadata of a class which express methods and properties and some characteristic of the class. So what do we have here? Here we have the metadata that is expressed by the super class, and we have to, in order to create an object of this type, we have to match the same reflection of the parent class. In this situation now is the reflection of sub. So we understand now that the reflection of super is matching the reflection of sub. We know that the subclass, of course, extends the superclass, extends with something else, some methods, some properties, and something that we find specifically in that subclass, but is not present in the superclass. So here we can think in that way. Here super is like to provide a sort of stamp, right? And in sub is actually having the same stamp plus something else. So it's easy to understand that we can't do the other way around, because if we do, for example, a type of specify object variable of type sub, and we assign create this object by instancing the class super, we understand that sub, actually the reflection of sub is specify something more that is not present in super. So how can super provide the information that sub requires?
simply it can't. So it's not possible to fulfill all the requirements that sub wants actually, and super is not able to do. But in this case, as we see here, super is actually giving requiring some characteristics, some properties, which sub in some way is able to give, because actually is parts is something that super belongs to. So if sub is not able to provide, because for example let's think that super has methods that sub doesn't override, and so sub can provide the relative methods. So in that case we use just the one that is specified in super, in the parent class. This is actually expressed well when we are going to see the output window here, and we see that in this case we see that when we find something that in sub is overridden, so like method 1 that is overrides the method 1 in sub overrides the method 1 in super, the output provided by the class sub. In other methods here, we are going to take the one that is present in the super class. I like also to finish everything just to say something that is I wrote in this code here. Is in method 2 I add this method here, which is method 5 only in sub. If we instance these methods here and we call these methods from the code in the main class, now is commented here, but if we call this method we are going to have an error because this one we know that as I said before, that super is providing the stamp, the reflection that sub must match, but in that case we are going to call something that is only present in sub and not in super. So the compiler gives error, and as we can see here, yeah, this generates error. The error is here. So type super does not contain a definition of method math 5 only in sub. The last keyword we are going to see is the seal keyword. This keyword is applied to methods in the child class which are overriding same methods, relative methods in the superclass. With seal keywords in the declared in the subclass, we say that that method can be overridden any further. So if we have another class that is inheriting from a subclass, this subclass can't override the method that is declared as sealed. Let's see here with an example because maybe it's better. So let's start. We see here we have this. Okay, this method here in the superclass, right? It's will be sealed method. So it's explaining, the name is explaining what we are going to do, and it's a virtual method. So it's possible to override in the subclass, and we do that. Actually, we see that this one is overridden here, And then we create another subclass. This subclass is inheriting from the subclass, and itself also overrides the same method. So will be sealed method is overridden also in the subclass. When we execute this code, and we are going to now to the output window, we see that here we have the superclasses from, okay, this is the text that is printed from the superclass, is from will be sealed method in the superclass, okay. Then we call the same method here with a super covariant approach. We actually, just because this one is overridden from the child class, so we execute the code that is in the child class, right? So this one is from the seal method will be better in the subclass. Also, then we execute the same method, right, in the subclass with the text that is there specified, and we see that actually we have the output of this method in the subclass. So now we do the same thing, but we are going to declare this as sealed, okay? And we execute the program. Now we see, oh, now we have the error. We have an error here, very, very clear. Everything is red, so it's because it's sealed, so it's very, very clear what is going on here. So with this last example, we finish this demonstration of these three keywords: base, new, and sealed. We had also a little discussion at the covariant polymorphism aspect. We had a discussion about that and some application of this. And with this one, see you next time.